Recording of me working on the math labs that we did on inverse functions in class. So I'm going to copy the data from some students here. So the first one I'm going to do is the cubes lab. So get rid of that, and I'm going to add a table. And the x's were like 10, went with 6. Then this person had 4 with a 15 and a 30 with a 2. And 6 with 10 and 15 with 4 and 2 with 30, 60 with 1, 20 with 3, and 3 with 20, and 12 with 5, and 5 with 12. And as I type those in, it should be plotting points, and I just have to get to where I can see them all. And I can see a curve here. And so now I want to write an equation. So I'm going to go down here and say, well, if I wrote in y equals 1 divided by x, I sort of get a curve that does this, but not in the right place. Now, it's still, this curve looks like it's going to have an asymptote. It'll never get to 0. And you think about that. If I'm trying to make an area, I can't go 0 for the width, or I can't go 0 for the length. So there will be no place where this will be 0 on this side or this side, but it'll get closer and closer. However, I can't do anything but these kind of points because I'm limited with integer values for x. So my domain is going to be 1, 2, 3, 4. Can't do. I can do 6. We'll see. This is at 2. I could do 1. It's up here, I think. Way up at 60. Oh, he didn't. That one wasn't in on the one I did. Is there 60 this way? Yeah. So I can have 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. So there's only one point that this person didn't have, and that was 1 and 60. Those are the ones that make this graph. 60 all the way down to there. So the domain is going to be limited to these numbers, and the range is also limited to the same set of numbers. The domain and range are equal on this. Can't do any negative numbers because we can't talk about negative number of tiles. But the equation, still going back to the equation, well, we're finding out that, and it's pretty clear that you realize that it just has to be 30 times 2 or 15 times. They always multiply to be 60. So I could write the equation as xy equals 60, and it should fit perfectly. But I could also do it as 60 divided by x, and it would fit perfectly. Now, if you were just kind of guessing and you said, well, let's try 10, well, it's not out far enough, and you try 100 and divided by x, get the other x out of there. That's too far out, and eventually you should come up with 60. But 60 relates to this problem in that that's what these multiply to be. That was the area. The area divided by one of the directions, the length or the width, gives the other one. The If it's divided by the length, you get the width, or if you divide by the width, you get the length. So that's how that works. So this kind of function that has asymptotes like this comes from a real situation like this, where we've got a product of two things equal to a number. So now let's get rid of this and go to the circle lab, circle chords. And I'm going to take the data this person had. So we're going to add a table, and they had 55. They measured in millimeters. So these numbers may not match yours, and so you may have to do this on your own. 76 millimeters with 52, 95 with 41, and 98 with 40, 88 with 45, and 98 with 40. They had that already. So 40, 98. Oop. And they should have had 45 with 88. And they had 65 and 62. 65, 62. So they should have 62, 65. And if they had 55, 71, they should have had 71, 55. And they should have had 52, 60, 76. Okay, and so we're getting another one of these curves. And the equation probably should be just whatever these multiply to be. So if I went and down here and said, what does 55 times 71 equal? 3905. So probably it's x, y equals 3905 or thereabouts. That fits pretty close. We might go to 4,000. Whoop, wrong button there. We try 4,000, see what happens. Get rid of that bracket. That's pretty close. Maybe it's a little too far out, but you can see that the product of these is going to be a number. Or we could have written it as y equals 4,000 divided by x, or some number. So you're just going to adjust this number to match it. And once again, on this, we could have any numbers in between here, but there's a limit how small they could go. If you drew your circle, I'll write an equation of a circle. X squared plus y squared equals, let's make it 100. And I'm going to look at this circle closer. Wherever you pick your point in this circle, let's say I pick a point there, the shortest distance is going to be the smallest number, and the longer distance, if I pick the diameter that goes through that point, there'll be a maximum length of one direction. If I pick a point somewhere here, the maximum length I can get is on the diameter from there to there. That would be the biggest range, or biggest value, and the smallest value would be the short distance. So it depends on where you pick it, what the domain and range are, but that's kind of what happens here. But any number in between you can get by turning to different angles through your single point that you picked. Okay, so that's the circle chord lab. Now the teeter-totter is also one of these kind of equations, but it's a little bit different because I set up the numbering system a little bit different on it. So I'm going to clear these. Start with another table. And taking the information that was done by this person on one of the two metal rods or metal flat iron or angle iron that I brought. One, they found it was 5 pennies. And at 5 inches, they found it took 6 pennies. At 10, took 8 pennies. At 13, it took 10 pennies. And at 16, it took 16 pennies. At 17, it took 25 pennies. And at 18, it took 50. And they didn't do 19. So, if you take a look at this graph, the asymptote's over here someplace. Now, it turns out that since I numbered the ruler from the metal bar from 0 at the far end, working towards the pivot point, the balance point where it rocked, and that was about 19 or 20, depending on which metal you used. That will be your asymptote. So it looks like this asymptote might be, maybe it was only 18, somewhere around 18 or 19. So this whole graph has been flipped over, because normally it goes this way. Oops, sorry. Goes in this direction, like y equals 400 divided by x, going the wrong direction. And I can change the shape of this by modifying the 400. Maybe it was just 40. And it looks like it's bent more than that. Maybe it's 80 or 100. Let's put 100. So I'm getting kind of this curve, but it's in the wrong direction. I need to flip it. And I can either flip it vertically or horizontally, because there's a piece down here. So if I flip it vertically and bring this up to here and slide it sideways, or I can take this and just flip it horizontally. But either case, flipping it vertically, I put a minus outside. Flip it horizontally, I put a minus on the x. They do the same thing. I can't tell whether that flipped it up or flipped it horizontally, but that's the case. I need to slide it over so that instead of x equals 0 being the vertical asymptote, it's at, say, 19 or 18 or something like that. So I need to slide it over. To do that, I need to put on the x, to move it to the positive direction, I have to subtract, let's say, 19. Now, I'm getting close to this place. There might be a vertical asymptote, but let's work on the curve here. So I'm going to change this to, I need it bent more, so I'm going to make it maybe 150. No. 150. No, I need to bend it. Oh, I need to make it a smaller number. So let's go to 90. It's getting better. Maybe 80. Now it looks like I need to move the vertical asymptote over, so maybe it's 19.5, moving it over that way, and it looks like I need to go up a little bit, so the whole thing might need plus 2, plus 2. It looks like I need to bend it sharper, so let's go to a smaller number here, 70. Getting better, maybe it's 60, maybe 50. Now I'm starting to get kind of close to them. Maybe go up a little bit more, 2.5. And you see how I'm starting to get it to fit pretty well. Maybe 45. And maybe not quite over there. Maybe go back to 19. And maybe up a little bit more. 6. And I'm now pretty much touching all the points of their data. So my equation is basically y equals some number over x, but flipped and slid over to the positive direction, 19, and up 2.6. Okay? That's the idea of how you get a model for this kind of data. It's all based on the curve y equals 1 divided by x, adjusted and moved around, and that's why we're doing these rational functions, because they have asymptotes like this does. This has an asymptote at 19. There's no x-intercept, so it'll never cross the x-axis for the data. It does over here, but this is beyond where the actual data can be. So this is out of the domain. This part is in the domain. Okay, hope that helps you finish up the lab if you haven't done it.